to be back with you this afternoon. One of the areas where people attack the Bible is they claim that astronomy has disproved the Bible. And I take issue with that as an astrophysicist. So what I'm going to do is share with you some truths of astronomy that confirm the Bible and recent creation in particular. Because again, people's claim, you hear these claims about, well, we know the universe started in a Big Bang and billions of years ago. No, you really don't know that. What we know is that the universe is here and it's beautiful. And when we examine it, we're going to see that when you look at these secrets of the cosmos, they really do confirm biblical creation. And there are 5 secrets of the cosmos that I want to cover with you this afternoon. We're going to see, first of all, how the glory of the Lord is revealed in creation, something that the Bible teaches. And it's certainly, the universe is consistent with the creation of the mind of God. It's not consistent with random chance processes. We're going to see how the basics of astronomy are confirm what the Bible teaches. And by basics, I mean things you would learn in a freshman level astronomy class. You see, the Bible does touch on astronomy. It's not a textbook. It's a history book primarily, but it's written by inspiration of God. It's inerrant, and therefore, when the Bible touches on astronomy, and it does, it mentions things like stars and so on. When it does that, it's right, and we're going to see that the evidence is consistent with what the Bible teaches. We're going to see that the Bible is right when it speaks to the issue of the age of the universe. And that's something where my secular colleagues, they believe in the billions of years. You need that for evolution to sound remotely plausible. But there's evidence that the universe is the age the Bible indicates, which is in thousands of years, not millions or billions. We're going to see that the Bible is right when it speaks to the uniqueness of the earth. In the secular view, the earth is just one planet among hundreds of billions in our galaxy alone. In the biblical view, earth is very special. That's not to say there aren't other planets out there. I think we know there are other planets out there. We can see them. But the Earth is very special because it's designed for life. It's different from the other planets. It has a special place in God's creation. And then finally, we're going to deal with the starlight issue, which is a question that many people ask. A lot of people think it's a defeater for biblical creation. Well, if the universe is only thousands of years old, then how can you see galaxies that are billions of light years away? So that's what I'm going to talk about. I'll spend a good amount of time on that because it takes a little while to unpack that issue. So let's jump right in and talk about the glory of God being revealed in creation. And I'm going to argue that the size and the beauty of the universe confirm biblical creation. The Bible says the heavens declare the glory of God, the skies proclaim the work of his hands. And so when we look out into the universe, we see God's glory revealed there. It speaks to God's majesty, his awesome power, his beauty, his glory. And again, there are a number of ways in which the universe does that. I'm just going to focus on 2. The size of the universe, which is something that is absolutely incomprehensible. But I can at least give you a little bit of a flavor of it, give you a sense of the scale that we're dealing with here, and therefore the power of the God who spoke this into existence. And the beauty of the universe, too. God is a masterful artist, and he has painted beautiful artwork on a canvas of unimaginable size. And that is something that you don't need to be an astrophysicist to appreciate. You can go outside and look up, and it's just beautiful. And as we've developed, as technology's improved, we can peer deeper into space, and we just see beauty upon beauty. And that's indicative of the biblical God. So let's start with the moon. Yeah, this is a mosaic image of the moon that's been pieced together. That's why it didn't match up the contrast correctly in certain places. But it was taken by the Lunar Reconnaissance Orbiter. We actually had a spacecraft orbiting the moon, taking high-resolution images of its surface. We put those together, and there's the moon in incredible detail. The moon is about the same size across as the United States, just to give you a feel for it. So if you could put the United States, imagine a map of the United States of America, it would cover up the moon, maybe go a little wider on the sides, but not quite as far north-south. So it gives you a feel for it. And that's something that we can kind of picture. But this will be one of the smallest things that we talk about today. So that gives you a feel for the size of the moon. And of course, it's amazing to me. We've had people that have actually walked on the surface of the moon. And yes, that's for real. It's not a hoax or anything. People ask about that. In fact, you can confirm it. We left a reflector on the moon when we landed there. And that is a specially designed set of mirrors that reflects light directly back from the direction from which you came, and you can bounce a laser off that and measure the time. And sure enough, 3 seconds later, you get the return image. So there's no doubt about that. I love showing people the moon in a small telescope. It's really beautiful. And people are like, wow, that's amazing. And then they say, can you see the flag? And I said, well, no, this is the size of the United States of America. You're not going to see the flag that the astronauts fly. But with the Lunar Reconnaissance Orbiter, we actually can see some of the details. This is Mare Tranquillitatis. This is where the first moon landing took place. And if we zoom in on that, you can actually see the lower section of the lunar module there. That's it right there. Remember when they launched, they left the lower portion. Remember that spider-like looking structure? That's the lunar excavation module. When they launched only the top portion of it to save fuel, so the bottom portion is still there. We can still see it today. And you might notice too, that little dark line that goes over to that crater and back. That's the footprints of the astronauts as they walked along the lunar surface. So the moon doesn't have any weather because it doesn't have an atmosphere. It's a substantial atmosphere. And so footprints stay around for a long, long time. Pretty neat. Some other instruments that they left on the surface too. So yeah, it really did land on the moon. There you go. The scale of the cosmos is as amazing as its beauty. So here's the moon, and I actually enjoy looking at it when it's in the first quarter phase like that, where it's illuminated right down the middle, because it brings out the craters. And you can tell it's spherical too, which speaks not only to God's design of the moon, but God's design of your brain. The fact that just based on the way the light hits the craters, your brain immediately, especially when you're looking at it in a telescope, your brain immediately recognizes that's a sphere. It's kind of amazing. Whereas when it's in full, you don't see the shadows of the craters because the sunlight's illuminating it directly from above. And so it looks flat as a dime when it's full. But when it's in first quarter phase, you can tell it's a spherical moon. Here it is compared to the Earth. So again, that gives you a bit of a feel for the size of these things, because we have a little bit of a feel for the size of the Earth. If you've driven a great distance, if you've ever driven through Kansas, you're like, we live on a big planet. Here's the Earth compared to Saturn. Earth's pretty small when you get compared to some of these larger planets like Saturn. Saturn, the planet, is about 9 times the size of the Earth in diameter. And the rings extend out even further. The rings are trillions of tiny little moonlets that orbit around Saturn's equator. They're quite beautiful, quite stunning. All of the large planets, Jupiter, Saturn, Uranus, and Neptune, they all have rings. But Saturn's are especially thick, and therefore they can be seen with even a modest telescope here on Earth. And they're fun to look at, too. You say, well, we've got some pretty good big planets in our solar system then. That's 9 times the size of the Earth, but that's pretty small compared to the Sun. The Sun is quite a bit bigger than Saturn and Jupiter. The Sun is about 100 Earths across. If it were hollow, it could hold 1,000,000 Earths. It gives you a feel for the size of that. So just imagine 100 little black spots lining up across the disk of the Sun to give you a feel for the size of the Earth in comparison. The Sun's basically a stable hydrogen bomb. It's fusing hydrogen into helium in the core, and that's an extremely efficient source of power. So the Sun has plenty of energy. It's not going to run out of fuel in the foreseeable future, let's put it that way. You're not going to have to worry about that. So the Sun is a star. We tend to not think of it that way, but it is. Or rather, those other little pinpricks of light you see out in the night sky are the same type of thing the Sun is. And it's just that they're much, much further away. The Sun is close. It's only 93 billion miles away. These other stars are in the trillions of miles away. The next nearest star is in the trillions of miles away. Now, the Sun is what we call a main sequence star. Main sequence star means it obeys a rule, where if you know the mass of the star, then you know everything else about it. You know its color, you know its size, and its luminosity too, how bright it's going to be. So everything else is known if you know the mass. And the Sun obeys that rule, and a lot of stars do. The Sun is actually larger than most stars. Most stars are red dwarfs. A lot of red dwarfs out in the universe, but we tend not to see them because they don't stand out very much. They're not very bright, they're not very luminous, and they're smaller than the Sun. So a majority of stars are red dwarfs. But there are some stars that are bigger than the Sun, and these are the ones we tend to notice because they're brighter than the Sun. For example, Mintaka, this is one of the stars of Orion's belt. Those 3 beautiful blue stars in our winter sky. So Mintaka, that's what we call a blue supergiant. There are stars larger than Mintaka, for example, Canopus. which I don't think you can see from this latitude, but if you go down into the southern states, you can see it in February in the evening skies. It's a beautiful, bright star, a white supergiant, very pretty. But there are stars, and think about that, okay? So here, you have the sun down there, right? And then you have the sun right there, and then you have Mitaka and Canopus. The sun's 100 Earths across, so this is really big. And then there are stars bigger than Canopus, like Antares, for example. It's a red supergiant. So the size is just hard to fathom. Antares is over 600 suns across. The sun is 100 Earths across, and you multiply that out, and it's really, really big. Amazing. Some stars are kind of like the sun, they're by themselves. Some stars come in binary pairs, and then some stars come in these amazing clusters. This is called a globular star cluster, and these are part of our galaxy. They orbit kind of around the center of our galaxy, and we think there's about 100,000 stars in that cluster. And it's only about 50 light years across. Light year is 6 trillion miles. So and they're quite beautiful. These are so fun to look at in a small telescope. These are some of my favorite objects to view because there's just a beauty there. And it's one thing to look at a picture, but when you see it with your own eyes, there's something special about that. It's really neat. And it reminds me of the verse that says that God calls them all by their names. God has a name for each one of those stars and a purpose for it. And they glorify God. Some of my favorite objects in the universe aren't stars at all, but nebulae. Nebula, the word nebula is Latin, it means cloud, and we see these glowing clouds out in space. And they're not clouds of water vapor like in Earth's atmosphere, but they're clouds of hydrogen gas, hydrogen and helium gas, the two lightest elements. That's what the universe is made of mostly. We're made of the rare stuff, oxygen, carbon, and so on. You have some hydrogen in you too, because you got water in you. But so that's a cloud of hydrogen, helium gas. And if there are stars nearby that gas, they'll cause it to heat up and glow, and you get these beautiful colors. And so I love to look at nebulae. I never get tired of looking at those things. And sometimes you'll get a star cluster nearby too. So here you get two for the price of one. You have the nebula up there and the star cluster down there. Really very pretty. And this nebula is enormous too. Our solar system, our sun, and all the planets would not show up on that image. It'd be less than a pixel. So it's enormous. There are different kinds of nebulae. Some are smaller. The smaller versions are called planetary nebulae. This is a planetary nebula. And so it's got, planetary nebula is about the size of the solar system. That's about as small as they get. So you have, and with a planetary nebula, there's always a star in the middle. Either a star or a star that's collapsed in on itself and no longer is fusing hydrogen. So you have the star in the middle there, and it's ejecting gas. And a lot of times it will form a two-lobe structure, like you see here. And that's because we think the star has material orbiting around its equator, and so the ejected gas gets kind of funneled out the north and south pole of the star, and so you end up with that lovely two-lobe structure. We call that a bipolar planetary nebula because it's got the two poles. And then lots of planetary nebulae out there. They're all beautiful. Here's the Ring Nebula. Some planetary nebulae are round. And by the way, that's where they get their name, planetary. It has nothing to do with planets. It's just some of them look round and they look like an out-of-focus planet. That's the only connection there. But and it could be the ones that are round are also bipolar, but we might be looking right down the barrel, and so we can't see the two lobes. We don't really know because we can't get another angle on it. We're here and we're not going anywhere soon. So the Ring Nebula is one of the first that I learned how to find. You can spot it with a backyard telescope. It's not too far away from the star Vega. It's an easy one to find, very easy. It's in between two other stars, exactly in between. I know right where to find it, and it looks so cool to see that little glowing smoke ring. And with a small telescope, you tend not to pick out the colors because at night you're using the rods of your eyes, not the cones, and so you don't really see much color. It looks like a grayscale version of that, but it's still very beautiful. Because most places you point a telescope, you just see stars and stars and stars. It's beautiful, but they're stars. There's the sweet spot next to Vega where you'll see a glowing smoke ring, and it's so strange to see that little cosmic Cheerio suspended on nothing. You're sort of expecting it to expand out, which it is. It's enormous. And the star in the middle is now a white dwarf. It's a star that's collapsed in on itself. It's no longer fusing hydrogen. So now all of these structures, all of these stars and star clusters and nebulae are part of a much larger structure. You can see all the stars and nebulae in this very large region. This is a galaxy. So a galaxy is a collection of perhaps 100 billion stars would be typical. Our own galaxy, we think, has at least 100 billion stars in it. Some estimates put it up to 400 billion stars. That's a lot of energy. Especially considering the sun, which is just one star, puts out more energy in 1 second than 1 billion cities could use in an entire year. It's just, God has unlimited power. And so he freely demonstrates it in the things that he's made in this universe. So that's the Whirlpool Galaxy. It's one of my favorites. Again, you can see it with a small telescope. It doesn't look quite that spectacular because that's a Hubble image, but you can see it. And you get to dark skies, you can see that spiral structure very faintly. It's beautiful. And so that's where the stars are more concentrated in those spiral arms. Lots of galaxies out there, galaxies of tremendous beauty. There are galaxies of tremendous ugliness too. How about that? There are galaxies that have large, mysterious arrows next to them. You'll see that in all the textbooks. I've never been able to see the arrow, strangely. Always pointing to something interesting too. We have the Cartwheel Galaxy, where you have a galaxy that's surrounded by a ring of stars on the exterior. It's quite beautiful. We have the Sombrero Galaxy, which looks, they picked the right name for it. That's what it looks like. This is a spiral galaxy that's nearly edge-on. And we found that galaxies contain not only stars, but also gas and dust. And the gas and dust tend to concentrate around the equator of the galaxy, so it's blocking the light from the stars behind. And again, this is a galaxy you can see with a small telescope in springtime. So this is a good time of year to see it, actually. It's part of the Virgo supercluster. You just got to know where to look. And you can see that, even with this modest telescope, you can see the faint glowing galaxy, you can see that dark dust lane there. And I remember the first time I saw it, I thought that was just neat, because I'd seen pictures of it. There was that old sci-fi show, The Outer Limits, where they showed the different galaxies at the end. And when I finally saw this one, I felt like I had arrived. So pretty neat. There are galaxies that are in the process of collision. That's kind of interesting. But the distance between the stars is enormous, so the stars are just going to pass all by each other. So it's totally harmless for those galaxies to cross that way. As we go deeper into space, you find that galaxies come in clusters. So we have not only clusters of stars, we have clusters of galaxies. And so here you're seeing a cluster, you're actually seeing 2 clusters of galaxies there, one behind the other. Each one of them, those are not individual stars. Each one of those is a galaxy with perhaps 100 million stars. Each one of those. Pretty amazing. Go out even deeper into space, this is the Hubble Ultra Deep Field. Each one of those specks, those specks are not stars, those are galaxies at unimaginable distances. This is about as far out as we can look at the moment, although the technology is always progressing. But can you imagine that? Each one of those. And that's a little section of the sky about the size of the head of a pin held at arm's length. It's near the Big Dipper. Wow, pretty amazing. And to think God spoke all that into existence. And I love the way the Bible describes the creation of all these hundreds of billions of galaxies with hundreds of billions of stars each. It's summed up in this little phrase, he made the stars also. Genesis 1:16. As if it was just so easy for God to speak that into existence. And of course it was, because it's God. Not a problem at all. All made in 6 days. In fact, what you're seeing here was made in 1 day, day 4. Because you read the text of Genesis, God spent 5 of the 6 creation days working on the earth, making it right for life and creating life on it. It takes 1 day out, day 4, and makes the rest of the universe. Almost as an afterthought. Like, you know what would go really good with an Earth? How about 100 billion galaxies with 100 billion stars each? That would just be nice. And people have asked, why would God, expend all that energy to make a universe that's that big? I don't know, but if it was to impress me, he succeeded. I'm impressed. It certainly reveals his glory, doesn't it? So the universe does declare God's glory. There's no doubt about that. It's not a chance universe. It's deliberately designed. What about the basics of astronomy, things that you learn in any freshman level astronomy class? Did you know the Bible mentions some of those things? And I want to go through some of those. But the interesting thing is, there were times when much of what we take for granted about astronomy today, things that the Bible affirms, people didn't believe it. And I'll give you an example of this. The spherical nature of the earth. The Bible does indicate a round earth. I'm frustrated and embarrassed to tell you that there are some Christians who say, the earth's flat, and the Bible teaches that. You haven't read the Bible. The Bible teaches a round earth. Isaiah 40:22, the circle of the earth. Job 26:10. With Isaiah 40:22, they say, well, it could be a flat disk. but with Job 26:10, it's got to be a sphere, because it says that God inscribes a circle on the face of the waters at the boundary between light and darkness. And that boundary between light and darkness is what astronomers call the terminator. That's where sunset or sunrise are occurring. And the only way that can be a circle on the waters is if the earth has a spherical shape. There's no alternative to that. So there's no doubt that the Bible teaches a round earth. And Isaiah, the interesting thing, though, if you look at most textbooks will credit Pythagoras with being the first to come up with the idea that the earth is round. And Aristotle is usually the first to have considered to have proved that. But Pythagoras is 500 BC, Aristotle is 300 BC, Job, we think around 2000 BC. We can't put an exact date on it, but it's way older than Pythagoras and Aristotle, and so is Isaiah for that matter. Which means these verses were written at a time when most people thought the earth was flat, and yet the Bible is speaking of it as being round. Isn't that interesting? It's almost as if the Hebrews had some kind of divine insight into this issue, which of course they did. So, by the way, the idea that Christopher Columbus discovered the world was round, or that he was out to prove that, is a myth. Educated people already knew the world was round at the time of Columbus. He just thought it'd be faster to go that way, which turns out it isn't. But I'm glad he made the trip. The earth hangs in space. The Bible says God hangs the earth upon nothing in Job 26:7. Wonderful description of the nature of gravity. The earth literally hangs on nothing. It floats in space. It is tethered to the sun by gravity, but there's no physical thing that it rests upon. And that might have been hard to believe when it was written, because the early Greeks taught that the earth was a flat disk and floated in water. And frankly, that's far more intuitive, because we've seen things that can float. We know certain things can float in water. We've seen that. And so the idea of an earth being flat and floating in water, yeah, that makes sense. But a sphere that hangs on nothing, we've never seen that in our experience. It might have been very tempting for people to say, well, the Bible got that wrong, because the Greek scientists, they know what they're talking about. Flat earth on floating in water, that makes sense. And they would be wrong. They were wrong. The Bible was right. The earth does hang on nothing. The expansion of the universe is taught in passages like Isaiah 40:22. That's the same verse that talks about the circle of the earth, by the way. And other verses that talk about God stretching out the heavens as a curtain, spreading them out as a tent to dwell in, implying that God made the universe with some size, but he stretched it out since then. So the universe is bigger today than apparently when it was originally created. Perhaps not by a huge amount, but by some amount. And the interesting thing about that is that was totally contrary to secular thinking until very recently. Until the 1600s, people thought the universe was static and eternal. That was the standard secular view, that nothing beyond the planets changed. And it wasn't until the 1920s that this expansion of the universe was discovered by scientific means. Edwin Hubble and others discovered that galaxies, the farther away a galaxy is, the faster it's moving away from us and from other galaxies. It's as if the entire universe is being stretched out or expanded. And that's, of course, exactly what the Bible teaches in a number of places, not just Isaiah 40:22, a number of places. So the Bible had this one right thousands of years before it was discovered by scientific means. And frankly, there's no way the Hebrews could have known that except by divine revelation. Because in order to discover this expansion scientifically, you need modern technology. You need telescopes and you need spectroscopes. And the telescope wasn't invented until 1608, and spectroscopes were after that. So the only way they could have known that is if God had told them that, which he did. So it's pretty neat. And then, by the way, people ask them, well, does this mean a Big Bang, right? Because if everything is moving away from everything else, doesn't that mean that, billions of years ago it was all in a point of no size? Does that mean the universe exploded into existence 13.8 billion years ago? The answer is no. Just because something's expanding doesn't mean it exploded into existence billions of years ago. Some of you are expanding a little bit. That doesn't mean you exploded into existence 13 billion years ago. It just means you're bigger than you used to be. That's common to all of us, I'm afraid. See, the problem is just because things are getting bigger, that you can't assume that they started with no size. When God created the universe, the earth was already in it, right? He made the heavens and the earth together, apparently. Even though he hadn't put stars in there, he made space-time and the earth already in there. So he stretched it out a bit since then. There's no logical reason to assume that it ever goes back to a point. And then people, as a follow-up question, will ask, well, doesn't this at least support the Big Bang? Because doesn't the Big Bang predict that the universe would be expanding, and then we discovered there it is? No. The expansion was discovered first. The Big Bang, the idea of a universe coming from a point, was invented in 1931 as a secular explanation for this. Okay, so you got the cart before the horse, if you want to call that a prediction. It's not, it's a post-fiction, right? They discovered it first, and then the Big Bang was invented to explain it in a secular sense. But the Bible did predict it. The conservation of energy and mass are very important principles in physics. The energy and mass basically are the same thing, measured in different ways. That's what Einstein discovered, one of the things he discovered. And one of the principles of energy is that you can't create or destroy energy. You can transform it from one form to another, but you cannot create or destroy energy or mass. And we would expect that biblically because John 1:3, all things were made by him, by Christ. And on the seventh day, God ended his work. So we would expect that no new material is going to pop into existence because God ended his work of creation. He's still working, but he's not creating new things. On the seventh day, God was done by the seventh day. And if new things were popping into existence, that would mean God's still creating, which cannot be. He ended his work by the seventh day. Or it would mean something can come into existence apart from God, which cannot be because all things were made by him. And nothing's going to cease to exist either because God upholds all things by the word of his power. And by him or in him all things consist or hold together. So God maintains that which he created. He doesn't allow things to change, but only to a certain extent. And he doesn't allow things to cease to exist in a fundamental way. Now, it's hard to pin down when these were discovered by scientific means, but usually James Joule is credited with the discovery of conservation of energy. He's 1800s. So it's about 200 years ago that the science caught up with what the Bible had already taught. And by the way, James Joule was a Bible believer. And when you write about his discovery about the conservation of energy, he actually made an argument from Genesis. He says, it makes sense that no new energy is coming into existence because God's ended his work of creation. So, you see, if you're a good scientist, you base your thinking on Scripture, you tend to come up with good results. We'll see more of that in a little bit. Countless numbers of stars. The Bible describes Abraham's descendants as the stars of heaven and as the sand which is upon the seashore, which is a wonderful analogy, isn't it, for a humanly uncountable number. And indeed, Abraham's descendants are humanly uncountable, and certainly the stars of heaven and sand upon the seashore is uncountable. It's a great analogy. Might have been hard to believe when it was first written because the number of stars you can see in the night sky is a few thousand. 3,000, perhaps 10,000 if you have superb vision, okay? That's the number of stars you can see in the night sky. And then in 1608, a remarkable new invention, which they originally called a spyglass, that makes distant things look close. We now call it a telescope. In 1609, Galileo starts fiddling with it, builds his own. In 1610, he gets his best telescope yet, points it up, looks at the Milky Way, that cloudy band you see in the summer sky. Oh, that's not clouds, that's hundreds of millions of stars. Far more than the 3,000 and 10,000 you can see naked eye. And so it's not that it was a bad analogy when it was written, it was good. It's just we can appreciate it on a whole new level now. And that's often the case as we learn more about God's universe. We realize that the Bible it's not only true, but it has a depth of truth that we hadn't even considered previously. Interestingly, throughout most of the Middle Ages, most astronomers believed that there were exactly 1,022 stars. It's true. Why would anyone believe that? There was a philosophy at the time that everything worth knowing had been discovered by the Greeks. And the Greek astronomer, I think it was Ptolemy, maybe it was Hipparchus. In any case, the Greeks had, I think it was Ptolemy, he had cataloged 1,022 stars, labeled them, put their positions, mapped them. Now, he never claimed the list was exhaustive, but since those were the only ones reported by the Greeks, the thinking was, well, those must be the only ones that exist, despite the fact you can see more stars than that. So it really shows you how a philosophy can affect your perceptions in a very negative way. So in all of these cases, there was a time when people thought the Bible was wrong. In all of these cases, the Bible turned out to be right. Every single one. So you get the point. Have you learned the lesson of history? In the past, whenever the experts of the day disagreed with the Bible has always turned out to be right. What about today? Have we learned the lesson of history? I hope you have. Not everyone has. Because there are people today who say, yes, well, I mean, the Bible got lucky on those issues, but today we know it's wrong about some things in astronomy. And one of those things they say, well, we know the Bible got this wrong, is the age of the universe. Because the Bible teaches about 6,000 years ago that it was that God created the heaven and the earth and all that's in them. But secularists say, no, we know the universe is billions of years old. Well, I got news for you. There's a lot of scientific evidence that only makes sense in light of the biblical time scale of thousands of years. And the Bible is clear about that time scale. The universe made in 6 days. In fact, again, most of the objects beyond the earth, all the objects beyond the earth, were made on day 4 anyway. So they're actually the Earth's actually the oldest thing in the universe, really, because it's made on day 1. The other luminaries are made on day 4. That would include planets, by the way. It says he made the stars also. The Hebrew word for star, kokab, would include planets as well. They're wandering stars. We classify them a little differently today. But the Bible teaches a young universe, and there's a lot of evidence that lines up with that, such as the excess internal heat of the giant planets. Jupiter actually gives off more heat, more radiation into space than it receives from the sun, by a factor of 2. So it receives 1 unit of energy from the sun and emits 2. Gets 1, emits 2, which means Jupiter's constantly losing energy, right? It continually spends more than it brings in from the federal government. So, and like the federal government, it can't do that forever, because eventually it runs out of energy. And you can think of it like a potato that you just take it out of the microwave. It's nice and warm. You can feel the heat coming off of it, right? If you put your hands close to it, you can feel that heat either by radiation or convection. And well, Jupiter's doing that too. And if you think about it, you come back to that potato, you leave it there, and you get a phone call, get distracted, you come back an hour later. It's cold. It's radiating away all its heat, right? It's come to equilibrium with its environment. Jupiter's doing that, but it still hasn't come to equilibrium with its environment, which means it's not very old. It wasn't that long ago that God heated it up. Okay? Jupiter's just come out of the microwave, and that's why it's still relatively warm. If it were 4.5 billion years old, as the secularists say, it should be an icicle by now. But it's still relatively warm. And I mean relatively warm compared to the environment. It's cooler than Earth by quite a bit. But it's still emitting more energy than it takes in. And the problem is even worse for Neptune. Now, Neptune's colder, it's further away, but Neptune gives off 2.6 times as much energy as it receives from the sun. So again, it takes in 1 unit, gives away 2.6. It takes in 1, 2.6, and so on. And it's been doing that since creation. It's big enough, Neptune's 4 times the size of the Earth in diameter, that it can do that for 6,000 years, not a problem. But if it were billions of years old, it should have run out of energy a long time ago. Magnetic fields are an indication of a young universe. I know the Earth has a magnetic field that protects us from charged particles that come from space, including those from the sun. And that magnetic field is caused by electrical current in Earth's core, and that current circles around and it creates that magnetic field. But electrical current encounters resistance, and so it decays, right? Batteries run down, and so the Earth's magnetic field has been decaying since creation. We think during the flood it decayed even faster because we think plate tectonics rapidly reversed the magnetic field due to the motions in the mantle. But aside from that, it's just been decaying. We expect that, based on first principles, that's the way most things in nature decay, is an exponential decay. And we've been able to measure that for the last almost 200 years. We know the Earth's magnetic field is decaying. There's no doubt about it. It's weaker than it was 200 years ago. And based on physics, we'd expect it was probably 20 times stronger at creation based on the current half-life and so on. But if the magnetic field, if the Earth were billions of years old, then the magnetic field, you run it backwards, it gets really strong. And if you press it back even 60,000 years, the Earth's magnetic field would be stronger than that of a neutron star, which is enough to rip the atoms of your body apart. So you can't even go back 1,000,000 years with a magnetic field. 60,000 would be an upper limit to the age of the Earth. Isn't that interesting? It's nowhere near millions of years. And now again, if you assume 6,000 years ago, the magnetic field would have been 20 times stronger at creation. Your compass would work better. That's pretty neat. You'd have increased protection from cosmic rays. That might contribute to increased health that people had in the distant past. So that magnetic field continues to decay today. And it's not just Earth's magnetic field. The other planets in the solar system Not all of them, but most of them have a magnetic field. Jupiter has an enormous magnetic field. It's still too strong today for life. So you gotta be careful about swinging too close to Jupiter. We actually have a spacecraft orbiting Jupiter. We had one, I don't remember if it's still in service, but the Juno spacecraft came very close to Jupiter. And they had to design it special to be able to withstand the electrical current that's induced as it goes through Jupiter's powerful magnetic field. They had put it in what's called a Faraday cage to be able to protect its circuitry. There was some question as to whether or not it would be able to survive, which it did. It was well designed. But think about that. Look at that powerful magnetic field. How could that be if Jupiter's billions of years old? Why hasn't its battery run down yet? And the answer is because it's nowhere near billions of years old. It's thousands of years old. The planets Uranus and Neptune. This is Uranus. It's tilted on its side, so it rotates this way. It rolls around the sun. And then it's got its magnetic axis is not aligned with the rotation axis. On Earth, the magnetic axis is close to the rotation axis. It's a little bit off. Or the magnetic north is up somewhere in Greenland, but it's close to the rotational north. With Uranus, not even close. Not even close. But the magnetic field is quite strong. And that was a surprise to the secularists because they thought, well, that far away from the sun, and it's billions of years old, the magnetic field should have run down a long time ago. And so that was their speculation. But Dr. Russ Humphreys, he's a friend of mine, he's a biblical creationist and a physicist, PhD in physics. He actually has a model for how God might have initially started the magnetic fields of the planets, and based on 6,000 years of decay, he can calculate what the current magnetic field is for any planet and moon in our solar system. It's pretty neat, and it works well. And he came up with this model back in 1984, before any spacecraft had visited Uranus or Neptune. And he says, well, based on this model, the magnetic field of Uranus should be this much. And when Voyager 2 flew past it, because the secularists were thinking, no, it'll be gone, it'll be dead. But when Voyager 2 flew past and measured it, it was the amount that Russ Humphreys had predicted within the error bars of his calculations. So it's an example of how, if you want to get right answers, you better start with biblical presuppositions. And it's like also with Neptune. Russ Humphreys also predicted the magnetic field of Neptune before it was measured by Voyager as well. And so his predictions were 84. The Voyager 2 flew past Uranus in 86, and then Neptune in 1989, and verified Dr. Humphreys' predictions. And my secular colleagues, they were scratching their heads about that. They're like, well, how do we explain these magnetic fields? And there's almost a rescue device. They say, well, maybe there's some kind of recharging mechanism, which they refer to as a magnetic dynamo, that somehow is powered by the planet's rotation, and somehow that energy gets turned into electrical energy. It's kind of like the alternator in your car. You can turn mechanical energy into electrical energy, but it takes a sophisticated mechanism to do that. The alternator in your car takes multiple parts working together. There's no evidence of anything like that in planets. So as far as we can tell, the magnetic fields, which all the large planets have, including Saturn, it's just indication that they're not billions of years old. They're 2,000 years old. The recession of the moon. Yes, the moon is actually moving away from the Earth due to tidal forces. The moon induces tides on the Earth because its gravity pulls on Earth's oceans. The tidal bulges get ahead of the moon because the Earth rotates faster than the moon orbits. And therefore, they pull forward on the moon. And when you pull forward on something in orbit, it moves out. I know that's a little counterintuitive. But if you've ever played with a gyroscope, you know that when things are spinning, they don't always behave kind of like you would expect. You push on the gyroscope that way, it moves that way. Same with the moon. You give it energy, it moves out. We can measure that. Remember that reflector that we left on the moon? You can time the trip it takes for a laser beam to get there, bounce off, and come back. And that gets you the distance to the moon, not the speed of light. And the moon is moving away by about 1.5 inches a year. Okay, so it's not a huge factor. But in the past, if you run that backwards, that means that in the past, at creation, the moon would have been 730 feet closer to the Earth. 730 feet, not a big deal considering it's 240,000 miles away. What's 730 feet in France, right? But if you do the math properly and you go back beyond that, and you do have to do the math properly because if you think about it, when the moon's closer, the tidal bulges would be bigger, and so they would exert a greater force on it. It would be faster, wouldn't it? So if you're watching the movie backwards, the moon gets faster and faster and faster and faster, and it turns out, if you do the math, it dives into the Earth at 1.4 billion years in a hypothetical past. So that sounds like a big number, 1.4 billion years. Yes, but the secular view is that Earth and Moon are 4.5 billion years old, you see. But just based on tidal recession, they cannot be older than 1.4 billion years. That's a problem in the secular view because 4.5 is greater than 1.4, right? The Common Core folks getting that? Right, so. We talked about comets previously, and how they don't last more than 100,000 years maximum. That would be for a typical comet. So, because the icy material gets blasted away every time they orbit the sun. I've seen comets that have been totally obliterated. There's a comet Ison that came around a few years ago. It doesn't exist anymore. It's been totally destroyed as it went around the sun. So yeah, lots of evidence like that. Spiral galaxies. The way galaxies rotate. Galaxies, not all galaxies are spirals. Some are elliptical. The spirals are very common. And spiral galaxies rotate differentially, which means the stars near the core make a loop faster than the stars at the exterior. Okay? Because they're on the inside track. They have less distance to go. So they make a loop quickly. The ones on the outside take longer. And if you think about that, that means that structure, that spiral structure, think about what happens if the inner portions spin faster than the outer portions. That spiral structure gets tighter and tighter, doesn't it? The spiral arms will become increasingly wound. And this is known as the spiral winding problem. In secular literature, it's the spiral winding problem. In creation literature, it's the spiral winding feature. Because we would expect that in 6,000 years, this hasn't rotated very much. The stars very near the core have perhaps made a complete loop, or maybe even a few, but the outer stars haven't rotated even once in terms of revolved around the galaxy even once. And so this is an indication that galaxies are nowhere near billions of years old. I actually ran a computer simulation. I need to incorporate it into this presentation, actually, if I can figure out how to do it. But, where I actually sped it up, and I said, what happens if what would galaxies look like if they were a billion years old? Because in the secular view, galaxies are supposed to be 10 billion years old. But I found that if you run it forward in time, even 100 million years, the spiral structure is not recognizable anymore. It's totally smeared out. It's like one of those old-fashioned photograph records. That's how tightly it is spiral. So there's no way they're near. They don't appear to be anywhere near billions of years old, or even hundreds of millions. They're consistent with a few thousand years. You might notice that the arms of that galaxy look a little bit bluish. And that's true. That's because they have a higher proportion of blue stars. And the interesting thing about blue stars is they cannot last billions of years because blue stars are the hottest, brightest stars in the sky. Most of the stars you see in the night sky are blue, even though they're rare. How can that be? Well, because they're bright. The red ones that are faint, you don't see them. You don't see nearly as many of them. The red ones have to be really close or you don't see them if they're red dwarfs. Blue stars expend their fuel quickly and can't last millions of years. We can calculate that. We know how much fuel's there. We can estimate the mass of the star. We know how much fuel. It is its own fuel, right? Because it's made of hydrogen gas, and when it converts hydrogen to helium in the core, that emits radiation. That's what powers a star. So you calculate the amount of fuel available, and blue stars have the most fuel. It's just that they use it up at an alarming rate. They're kind of like the SUV of the star world. They have a big gas tank. They just get really poor gas mileage. And so they can't go very far in time. They can't last very long. And by the way, my secular colleagues would not bother to argue that. They know that blue stars can't last billions of years. They know that. And yet we find them everywhere. So what's the rescue device? Well, obviously there must be a blue star generator that makes new blue stars, right? And so if you've heard of stellar nurseries and things, we think this is a stellar nursery because new stars are being born here. No one has seen a star form ever. Okay? They can talk about it. You can say, we think this is a star forming region. You can think whatever you want, but you don't see stars forming there. And there are problems getting a star to form because stars are ball of gas. Now, once God makes a star, its own gravity will keep it there because it's relatively small compared to the size of the universe. And so its gravity will keep that gas there. But when gas is spread out in nebulae, see, the secularists believe that these nebulae that we see, those were pretty colorful things, collapse in and make stars by the gravity. But the problem is, when they're dispersed like that, the force of gravity is minuscule. And instead, what you have is gas pressure, and gas pressure makes gas expand, right? That's why you didn't worry when you came to this room that all the air might be in that corner. You assumed that the air would spread out, because that's what gas does, you see. So I don't think stars do form. The Bible doesn't say they don't, so I'll be tentative on that. But there's good evidence that stars, especially blue stars, which would be the most difficult ones to form, I don't think they do form. I think they're just evidence of a young universe. So the evidence is consistent with what the Bible teaches, so there's no doubts there. The Bible's right about the uniqueness of the earth. This is another category, aside from age, where my secular colleagues say, yes, well, the Bible got that wrong, because the Bible treats earth as special. God spends 5 days working the earth, only 1 day to make all the other planets and stars in the universe. Well, the fact is science confirms that the earth really is unique among the worlds of the cosmos. And one of the ways in which it's unique is that God formed it to be inhabited, the Bible says in Isaiah 45:18. So Earth has special features that enable life to exist here. The right kind of atmosphere, liquid water, things like that. It's got the right temperature range and so on for life to be possible. The other worlds of creation, they're beautiful. I'm glad God made them. The moon is spectacular. One of the astronauts who walked on the surface of the moon referred to it as a magnificent desolation. I think that's a wonderful expression. It has a beauty to it, the moon does, but it's not like the Earth. The Earth has all these wonderful colors. The moon is very, very gray. And there's no life on the moon. It looks like a desert on Earth. But even a desert on Earth has plants and has life. The moon is a magnificent desolation, not designed for life. It's at the same distance from the sun as Earth is, right? Because it's orbiting around the Earth, but it doesn't have the right atmosphere. It rotates too slowly. The Earth's designed for life, the moon is not. What about Earth's neighbors, Earth's next door neighbors? You got Venus over there on the left. That's a little closer to the sun than we are. You got Mars over there on the right. Mars is a little further from the sun than we are. Venus is almost exactly the same size as the Earth, just ever so slightly smaller. And there were times, you can look back in the older literature, where secular scientists thought that Venus might have life on its surface, and they were free to speculate because Venus is permanently enshrouded in clouds. And so it's always nice when you can speculate unfettered by inconvenient data. But the fact is, we now know that the surface temperature of Venus is 900 degrees Fahrenheit. Yeah. That thick atmosphere, super thick atmosphere, 100 times thicker than the Earth's. It traps in heat and creates a greenhouse effect. And that's what people say, well, that can't happen on Earth. It can't happen on Earth. Earth has only 1% of Venus's atmosphere, so that's not going to happen. We have just the right amount of greenhouse effect for life on Earth. But Venus, way too much. When lead is in a liquid state, probably not a place you want to visit. And those clouds, by the way, are made of sulfuric acid type compounds. So there's just lots of wonderful ways to die on Venus. It's not a place you want to visit. Mars is a little better. Mars doesn't have that thick atmosphere. It's got a very thin atmosphere. It's only about 1% of Earth's atmosphere. And by the way, if you've been following the news, you know that we have a lander on Mars that's just very recently, and it deployed a little helicopter. And we've actually successfully flown a drone on Mars, which I think is just awesome. I just think that's so cool. But we've been able to get a drone to fly in an atmosphere that's 1% Earth's atmosphere. And what a marvel of technology. But Mars isn't designed for life. You can't breathe in 1% atmosphere. I get when I go up Pikes Peak, and that's got, that's like 60% atmosphere. Also, Mars's atmosphere is carbon dioxide, which you couldn't breathe anyway. Plants might like it, but animals not so much. Human beings not so much. So Mars isn't designed for life either. It doesn't have any liquid water on its surface. Water molecules there, but not liquid water, because the atmospheric pressure is insufficient. So it's not designed for life, and it's bitter cold on Mars too, because it is further away from the sun. There's very little greenhouse effect. So it's kind of like Goldilocks and the Three Bears. You've got those two planets too cold, those two too hot, not too cold. Earth's just right, because it's made for life. And that brings the question of what about extraterrestrial life? I don't expect to find life out in space because Earth is formed to be inhabited. God doesn't say that about any other planet. And granted, that's, the Bible doesn't say there's not, extraterrestrial life out there. It's just my expectation. Of course, if you have intelligent life out in space, then you've got some theological problems you're going to have to think through, right? Because if there are Vulcans and Klingons out there, you realize they can't be saved because they're not related to Jesus. Under biblical law, only a relative can redeem you. The reason that Jesus can pay for our sins is because we're all of one blood. His blood counts for us on the cross, right? But Lieutenant Worf is out of luck because he's a Klingon. He's not descended from Jesus. Nobody to pay for his sins, so he's got a problem. They say, well, what if the Klingons never sinned? Well, then they're suffering the effects of the curse because Adam did. That doesn't work, does it? Well, maybe Jesus went and became a Klingon and died for them too. That doesn't work because the Bible says he died once for all. He's raised incorruptible. He's never going to die again. So if you have intelligent life out there, I think there's some theological issues. I guess if they found moss or something on a distant planet, that wouldn't be too problematic. But to be honest, I don't even expect them to find that. Earth is designed and for it to be inhabited. And so this brings up what's called the Fermi paradox, because in the secular view, life evolved on Earth because apparently when the chemistry's right, that's what happens as you get life. It's a huge universe. So there's probably other places out there like the Earth where life probably evolved, right? And given the universe is billions of years old, surely on some of these planets life evolved earlier than it did on Earth. That makes sense. And that means that some of these should have already developed spacefaring civilizations and should have colonized the galaxy by now. But the galaxy is not colonized. That's called the Fermi paradox. And it's a problem in the secular worldview, but it's a feature of biblical creation. What about the starlight issue? That's the one I want to end up on, and I want to spend a significant amount of time on this. Because it really isn't a problem for a young universe, but it takes a little bit of background information to understand what's going on here. So I hope you'll indulge me for a few minutes. The idea is that you have light from these distant galaxies, and my secular colleagues would say, we all know light's very fast. Light is extremely fast. Light travels 186,282 miles in 1 second. It's quick. Light could go around the Earth 7 times in 1 second. It's fast. But these galaxies are so far away that even at the speed of light, it should take billions of years for the light to get from there to here. And by the way, when we talk about a light year is actually a measure of distance. It's the distance that light would travel in a time of 1 year. So a light year is about 6 trillion miles, 5.88 trillion miles is what a light year is. And so when we talk about galaxies being billions of light years away, that's true. And we can talk about later if you want to ask me how we know that, but let me just tell you, let me assure you there's good science behind that. The universe really is big. It's enormous. And so these galaxies are billions of light years away. Now that in itself is not a problem, because when you say the universe is billions of light years in size, people hear that term year and they think time. It's not what it means. It means the universe is big. But considering light takes a year to travel that distance, to travel a distance of 1 light year, you'd think it'd take billions of years to travel the distance of billions of light years. And we do see these galaxies, so obviously the light has got here, right? Therefore the universe must be billions of years old. That's the argument. And this is one of the main arguments that secularists will use against biblical creation. One of the main ones. There's only about 2 that they use, to be honest, that they try to argue proves billions of years. Radiometric dating, distant starlight. And we debunked radiometric dating last night. So now I'm going to debunk distant starlight. I do have to point out, before I give you the right answer, I'm going to give you the wrong answer. Because if I don't, people will come up to me and say, have you thought of this, Dr. Loudness? We've thought of that. There's a reason it doesn't work. For example, some people will say, well, maybe the distances aren't real. Maybe all the galaxies are actually really close. They all have to be within 6,000 light years. Folks, even our own galaxy isn't contained within 6,000 light years. That's not going to work. The distances are real. There's good science behind that. We can talk about that later if you're interested. Some people have suggested that the speed of light is much faster than the past. And I think that was a great thing to try, because it is true that in many cases, secularists assume that a rate is constant when really it isn't. The rate at which canyons erode can be much faster under flood conditions, for example. But we've looked into this, so I'm glad people asked that question. Has the speed of light been constant? And the answer is, we think it has been constant. We think there's good reasons for that. Because the speed of light is not like other things. It's not like the rate at which canyons erode, which you can change the circumstances and change the rate. The speed of light is linked into certain other things, like the ratio between magnetic fields and electric fields. If you change the speed of light too much, then atoms would not even be possible. And so it's not a free parameter. So and there's no evidence that it's faster than the past. One suggestion is, well, maybe God made the light in transit. So when God made the star, he made a beam of light connecting the star to the earth. And that sounds really plausible at first, until you think about it a little bit. Because you see, light in transit requires God to create fictional images in movies. And let me explain what I mean by this. Here we have a picture of supernova 1987A. So on the left panel, the arrow is pointing to a star. That's the way the star looked before January of 1987. So throughout recorded history, that's what the star looked like. In 1987, in January, that's what the star looked like, because it blew itself to bits. Okay, very sad, blew itself to bits, but quite spectacular though. If you gotta go, supernova, that's what I said. I mean, because it briefly becomes as bright as the rest of the galaxy. And so that's pretty neat. And today, what does it look like? Well, the star's gone, but you can still see star guts expanding into space there. That's a supernova remnant, basically star guts, okay? And it continues to expand every year. It gets bigger because it's just, there's nothing to stop it. It's blown all its material out in space and it continues to expand out in space. So, the question then is, when did this happen? Well, 1987A. That's when we saw it. We saw it in 1987. This star, however, is in one of the Magellanic Clouds. It's at a distance of 168,000 light years, which means in secular thinking, the event actually happened 168,000 years ago, and the light from that explosion finally reached the Earth in 1987. Okay? But if you say, no, the way we're able to see this star, and the way we're able to see that explosion is God made the beam of light already on its way. But if you think about that, that means that that star never existed. Right? Because it's way beyond 6,000 light years out there. It's just rather, what you hear, this image that you're seeing here is just a picture that God made in a beam of light. A bunch of pictures, like a movie, motion picture, right? And then he made pictures of the explosion, and then he's made pictures. This doesn't exist either, if you believe that view. You see what I'm saying? And I have no doubt that God has the power to create fictional images. I just don't think he does. Because he's a God of truth, and he's not a God of deception, not the author of confusion. So, if the light in transit idea is true, then none of these things have actually existed. And that's a problem. We do see, if we didn't see things happen in space, I might be more agreeable to the light in transit view. But the fact that we see things explode in space, and that would imply that that never actually happened, that bugs me. Because in the Christian view, we can trust in the basic reliability of our senses. So, okay. Moving on to a little better idea, but I still don't think it's the right answer. Russ Humphreys, again, a friend and colleague of mine, he said maybe gravitational time dilation is the answer, in which clocks can flow at different rates. And Einstein demonstrated that indeed, time can flow at different rates in different circumstances. The problem with this is a solution to this in starlight, and I'm going to be very brief. The mathematics doesn't work. The difference in rates is so small that it cannot account for the starlight issue. And so those of you who've read the Humphreys book back in I think it was 94 that he published Starlight in Time. By the way, he doesn't hold to that model anymore either. So that's a bit outdated. I want to give you what I think the right answer is. And it's a little different from what people expect, but I believe this solution involves what we call the one-way speed of light. The speed of light on a single trip rather than a round trip. You see, whenever you see the number or the letter C in scientific literature, lowercase c, that stands for the speed of light, but that stands for the round trip speed of light. And it is always 186,282.397 miles per second in vacuum. Okay? That's always the rate at which light travels. But that is a round trip time averaged speed. What does that mean? Well, basically, it means that the experiments that have measured the speed of light can be boiled down to this. This is simplified, but you get the basic idea. So, what we'll do, we're going to measure the speed of light. So, we're going to, and I'm going to have a flashlight here and a stopwatch, okay, or a clock. And when my clock strikes noon, I'm going to turn the flashlight on for just an instant, send the light down a long hallway. To make the math easier, we'll make it 186,282 miles long. That's a long hallway. We'll pretend we have government funding. We can waste it that way. And at the other end of the hallway, we'll put a mirror. Okay? And so the light will go down the hallway, bounce off the mirror, come back. And as soon as I see the light, I know it's returned. Right? So you ready? I did it at noon, and then boom, comes back, and I look at my stopwatch. And if we did that experiment, it would take 2 seconds to see the flash. 2 seconds for the light to go out and return. Okay? And so we say, okay, it traveled a distance of 186,000 miles twice, because it had to go out and then back. And it took 2 seconds to do that, divided by 2. So you get 186,000 miles per second. So that's why I did it that way, to make the math easy. And most people assume that the light took 1 second to go out and 1 second to come back. And you can be forgiven for assuming that, because I depicted it that way. What we have here is really kind of a God's eye view, which is not something we have in reality. But if we had a God's eye view, we could see when it hits the mirror, and you could say, yes, it goes the same speed out as it does back. But my point is, we don't actually know that. As human beings who are not God, we don't know that. It could be, for example, that the light takes no time at all to get to the mirror, and then it takes 2 seconds to get back. You'd get exactly the same answer, wouldn't you? All I know is that from the time it takes me to hit the button, for me to see the flash, is 2 seconds. I don't know that it took 1 second to get to the mirror, 1 second back. It could have taken 0 seconds to get there, 2 seconds to get back. Or it could take 2 seconds to get there and no time to get back. All I know is the total time and the total distance. That's all I know. Now, what if the situation is the bottom situation down here? What if light, when it moves toward an observer, is instantaneous? And what if when it's moving away from the observer, it turns out it would have to be half c, 1/2 the round-trip speed of light, in order for the math to work out, right? Because all we know is it takes 2 seconds to make the total trip. Now you'd say, well, but why would it be different, Dr. Lisle? Why would it be different that way than that way? I don't know, but a good scientist doesn't just assume that it would have to be the same, because wouldn't that be nice, right? We can't just assume something because we like it to be true. It could be the case that the bottom is the real way the light travels. And if that's the case, do you realize that there's no starlight problem? Because if light, when it's moving toward me, takes no time at all, then there you go. God creates the stars and their light immediately reaches the earth. Not a problem. So I'm kind of hoping that this is the answer. But again, hoping for something doesn't make it so. Is there any way we could test to see if the speed of light's the same that way as it is this way? Can we measure the speed of light on a one-way trip? It's been attempted, but never successfully. Let me show you why. Here's what we have to do to measure the speed of light on a one-way trip. You can't use the mirror anymore because we don't want it to come back. We just want to measure it one way. Now I'm going to need 2 clocks, aren't I? I'm going to need 1 clock to tell me when to start the trip. When the clock strikes noon, send out the pulse. And then I'm going to need another clock to record the time when the light arrives. It's got a detector attached to it, and it'll freeze the clock when the photon arrives. And you might say, yeah, I think that'll work. And if we do that experiment, I think the clock there will stop at 12:00:01. I think it'll be 1 second past noon. Well, I got news for you. I did this experiment in my office. I had a clock on my phone. I have my watch. As soon as my watch struck noon, turned on the flashlight. Of course, it appeared to hit the phone immediately, but I looked at the time on the phone when the light arrived. It said 12:05. So obviously, the light took 5 minutes to get from here to there, right? I mean, it seemed like it was instantaneous, but hey, the clock read 12:05 when the light hit it. Yes. What's the false assumption there? That the 2 clocks were synchronized, right? Obviously, the clock on my desk is fast by 5 minutes. It's ahead of the clock on my watch. You get that. So my point is, this experiment will give you the wrong answer unless those 2 clocks are synchronized, unless they read the same time at the same time. We know what synchronized means from the old spy movies, when let's all synchronize our watches and make sure they read the same time at the same time. You say, well, no problem. We'll just make sure the clocks are synchronized. How are you going to do that? Usually the way clocks are synchronized is by radio transmission. In fact, one of the clocks I have does this. There's a radio transmitter in Fort Collins, Colorado. It's connected to the atomic clock in Boulder, and it sends out a signal. Maybe some of you have clocks that receive that signal. They set themselves to the atomic clock. So that the clock strikes noon, it sends out a radio pulse, and as soon as the other clock receives the radio pulse, it sets itself to noon. Now the clocks are synchronized, right? No, not necessarily, because that radio's fast. That radio pulse might take a little bit of time to get from one clock to the other, right? Now, if we knew how fast radio was, we could adjust for that. If I knew that radio took 1 second to get from there to there, when it receives it, instead of setting the clock to noon, I could set it to 12:01. No problem, right? If we knew how fast radio was. Do you know how fast radio is? Anybody know how fast radio is? Radio moves at the speed of light. Because it's actually the same substance as light. Radio and light are the same thing. They just have different wavelengths. And that's the very thing that we don't know, is the one-way speed of radio, the one-way speed of light. We know the round-trip speed. So the point is, you'd have to already know the one-way speed of light in order to synchronize your clocks so that you can then measure the one-way speed of light. So that's not going to work. Now, some people have thought that placing the radio transmitter in between the two clocks is the answer. Because then, yeah, maybe they'll both be behind the radio transmitter, but at least they'll be synchronized to each other, correct? No. Why? Because in order for those two clocks to be synchronized, the radio pulse would have to travel at the same speed that way as that way, which is the very question I'm asking. If not, then this clock gets set to noon first, and then that clock gets set to noon a second or two later. And they're not synchronized, you see. So that synchronizing clocks by radio transmission is not going to work, because you'd have to already know in advance what the one-way speed of light is, so that you can compensate for any time delay. Does that make sense? We're tracking here. I know this is getting a little deep. It's going to get worse, trust me. There's one other method that people have tried to use: slow clock transport. Since you can't synchronize them by radio pulses because we don't know what the one-way speed of radio is, the idea is, well, we'll synchronize the two clocks at the same location, and then we can be sure they're synchronized because they're both radio. That's fine. And then we move one of them, or both of them, to opposite ends of the hallway. And the assumption is that they're still synchronized. The problem is, motion affects the passage of time. Einstein discovered that moving clocks take at a slightly different rate than stationary clocks. Now, the effect is small, but when you add it up over 186,000 miles, it can make a huge, it can be off by a second or two, and that makes the difference between the speed of light being half c or infinity. So it makes a huge difference. Now, the good news is there is a formula that tells you how much the time is affected by that motion. And so if we plug it into that formula, we can figure out, okay, that clock lost a second when we moved in there, so we need to advance it 1 second. The problem is, in that formula is the speed of light. The very thing I'm trying to measure. Okay? So here's the conundrum. It's a dilemma, right? It's impossible to synchronize two clocks separated by distance without already knowing the one-way speed of light, so that you can be sure they're synchronized. And it's impossible to measure the one-way speed of light without having two synchronized clocks separated by a distance. You realize what that means? It will forever be impossible to measure the one-way speed of light. It can't be done. Because each condition requires you to know the other one first. To know the one-way speed of light, you have to know the clocks are synchronized. To know that clocks are synchronized, you have to know the one-way speed of light. Now, when you have a conundrum like that, that suggests that the one-way speed of light is not a property of nature at all, but a convention. A convention is something that we get to choose, and if we all agree to it, it works, like driving on the right side of the road. Or 12 inches in a foot. Who decided? How do we know there were 12 inches in a foot? Who decided that? I need to look that up. I don't actually know. But at some point in history, somebody decided there should be 12 inches in a foot, right? That's perfectly arbitrary. Now, we all agreed to it, so that's the way it is. But how do you know that? Well, because we defined it that way. But had history been different, we could have decided inches are a little bigger, we could have made, or if it's a little smaller, we could have made 10 inches in a foot. It's arbitrary, we get to choose. The one-way speed of light is like that. It's a humanly stipulated convention. This is where I really lose people. So if you think that's weird, because it is weird, it's counterintuitive, I know. Because you'd think, well, the speed of light is either this or that. But because the nature of time is not absolute. Our intuition tells us that time is the same everywhere. Einstein discovered that it's wrong. And we have abundant proof of that today. We measured it with atomic clocks and so on. So apparently the speed of light in one direction is not something we measure, it's something we choose. And then that tells us how to synchronize clocks, which means I'm free to choose the one-way speed of light to be anything between 1/2 c and infinity. Now, the round-trip speed is set by God, so I can only set it in one direction. I can make it infinite in one direction, but the other direction would have to be 1/2 c. And as a matter of fact, this is something that is written about. Imagine a lightning bolt at M. M is a point exactly between two clocks. And the idea is you want to synchronize those two clocks using the lightning bolt. Okay, so the lightning bolt strikes, the light goes out to A and B, and as soon as the light arrives, they both set themselves to noon. And you think, well, that ought to synchronize them if the speed of light's the same in both directions. But that's not something that we can measure, it's something we just decide. That light requires the same time to traverse the path A to M as for the path B to M is in reality neither a supposition nor a hypothesis about the physical nature of light, but a stipulation which I can make of my own free will in order to arrive at a definition of simultaneity. That was written by Albert Einstein. Einstein realized that the one-way speed of light cannot be measured. It's something we simply stipulate. And usually what most physicists do is they'll make the speed of light the same in all directions because it makes the math easier. It does. But it turns out you don't have to do it that way. John Winnie proved in the 1970s that you can do all of relativity with having the speed of light be different in different directions. Because it's just a humanly stipulated convention. And the interesting thing is, all ancient cultures used a different convention than we use today. In ancient cultures, they defined the speed of light to be infinite when it's moving toward us because they had no other choice. They didn't know what the round trip speed of light is, and therefore when you see something that happens in space, that's when it actually happens. It takes no time at all for the light to reach you. That's an ancient convention. I call it the anisotropic synchrony convention. Anisotropic means different in different directions. So when the light's going out, it travels at half c. When it's coming in, it's instantaneous. When it's at a right angle, it's c, and there's an equation for intermediate angles. And that makes the math a little more complicated, but it is inherently what all ancient cultures did. They didn't subtract off light travel time. Now, the interesting thing is, if the Bible's using that convention, and I think it is, then there is no distant starlight problem, right? Because in that convention, it doesn't take light any time at all to get from there to here. To send the signal back, that would take a long time. But it doesn't have to go back, it just has to get here. So there's no starlight problem if the Bible uses the anisotropic synchrony convention. And I think the Bible does use that for two reasons. First of all ancient cultures did. And the Bible was not just written for 21st century astrophysicists, it's written for everybody. It's written in a way that anybody can understand. It was the basic truths of it. Secondly, I think it's implied in Genesis chapter 1. In Genesis chapter 1, verse 14, then God said, "Let there be lights in the expanse of the heavens to separate the day from the night, and let them be for signs, for seasons, for days and years." We find out later it's the sun, the moon, the stars also. Those are the celestial objects that God created. Then read the next verse. "And let them be for lights in the expanse of the heavens to give light on the earth. And it was so." Oh. So God not only created those lights to give light upon the earth, but they did give light upon the earth immediately upon their creation. And that suggests an anisotropic synchrony convention. Because in that convention, when you see something, is defined as when it happens. Now, I should point out to you that I'm not claiming that the other convention, where light takes, where light's the same speed in all directions, I'm not saying that's wrong. I'm just saying it's different. It's like the metric system versus the British system. You want to measure a room in meters, you want to measure in feet, you get a different answer, you get a different number, but it reflects the same underlying reality. And so I'm suggesting to you that there is no distant starlight problem because the ancient cultures, including the Bible, used the anisotropic synchrony convention. And there's no reason why we can't do that today as well. So I hope that you've seen that the Bible is right on all these issues. It's right about God's glory being revealed in creation. It's right about the basics of astronomy. It's right about the age of the universe, the uniqueness of Earth, and even the distant starlight issue.